This episode is brought to you by GPRS. Construction professionals know that utilities and concrete reinforcements can cause big problems when you're on the job. GPRS helps you avoid them. We use ground-penetrating radar to detect rebar, conduit, and post-tension cables before you cut, core, or drill. And our concrete scans are 99.8% accurate. We guarantee it, helping you reduce hits, downtime, expenses, and keep your people safe. To keep your job site safer, visit gprsinc.com. This episode is brought to you by Concrete Logic Academy. If you work in concrete, engineering, construction, or ready mix, you already know most of what matters isn't taught in school. That's exactly why we built the Concrete Logic Academy Unlimited Pro membership. You get unlimited access to 25 concrete courses, plus real-world breakdowns, research, and a community of professionals solving the same problems you are. Instead of paying for one course at a time, you get the entire library in one place, built for how you actually work. No travel, no hotel ballrooms, no sales pitches, just practical concrete knowledge you can use on your next project. Start your free trial at www.concretelogicpodcast.com/pro.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
All right, and welcome to another episode of the Concrete Logic Podcast. And today I have Doug Mouton with me. He's a global expert in hyperscale data center infrastructure with over 30 years leading design, construction, and delivery at Microsoft, Meta, and Jacob Solutions. He's a decorated U.S. Army colonel, retired. Thank you for your service.
My pleasure.
Doug has commanded units of up to 3,000 personnel and led recovery efforts in Afghanistan and post-Katrina, Louisiana. At Microsoft, he scaled global delivery to over 1 gigawatt per year, have costs and delivery times, and established best-in-class safety programs. At Meta, he drove design innovations, cutting carbon and cost by 40%. Doug now advises top firms through Mouton Advisory Services, offering strategic insight into digital infrastructure, AI impacts, and sustainability. Serves on numerous boards. It's like, do you have time for anything else, Doug? Come on.
It's a busy time.
Yeah, and he's a sought-after speaker. I'm happy to have him here. We've been going back and forth for a long time. We finally connected. So, Doug, thank you for coming on the show today. I appreciate it.
Thanks for having me. Thanks for your patience. I know we go back and forth trying to find time to connect, so I'm glad to be here.
So if somebody was going to guess what we're going to talk about today with Doug on here. We're going to talk about the data centers. So we're going to talk about how important concrete is to the data center industry growth and what we should be thinking about as an industry. But before we get started, I just want to remind everyone how you can support the podcast. If you go to www.concretelogicpodcast.com, there's a home page there. And on there's a couple ways you can get a hold of me. Ask Seth in the menu at the top, the navigation there. Click on that and you can shoot me an email. And what I'm looking for are topic or guest suggestions. A lot of our episodes are driven by listeners of the podcast. So get on there, tell me what you want to hear, what you want to learn about. If you don't like that option, there in the bottom right-hand corner, there's a microphone icon there. You can click on that, and somebody did this the other day, and what that does is leave me a voicemail. So you can just tell me what you want to hear, or whatever your idea is for the podcast. Please do that. The third way you can help the episode is on the same homepage, on the concretelogicpodcast.com homepage. There's a donation button in the upper right-hand corner. We typically don't advertise, but you might have been hearing some advertisement lately before the episode. But within the episode itself, I'm trying to keep advertisement out of that. And how you can help me do that is by donating to the show, and that helps keep the podcast going. So click on that, and you can give any amount. There's not a set amount on there. You tell me what the podcast is worth to you. That's how that works. And then the last thing is if you go to concretelogicacademy.com, there's a way for especially professional engineers to get their professional development hours, and it's built around the podcast. So same content, we just have more resources for you on the Academy. In addition to the content, there's quizzes to make sure you're absorbing what we're talking about, and it's a little bit more formalized in the podcast. So, all right, I'm out of breath. So we're going to talk about, again, how important concrete is to the data center industry's growth and what we should think about. And, work for Baker Construction. We rebranded Baker Construction. It's very important to me, but how important is it to the data center industry?
Data centers need concrete. They're the foundation of all the buildings. So we can't get a data center without concrete. It's a bit of a paradox, though, in the data center industry, because when the grand scheme of things, you look at the breakdown of all the materials that go into a data center, concrete is, single digits in terms of the total cost. But as we look at the evolution of the data centers today in the era of AI, in the era of bring your own power, we're now seeing gigascale projects. Look at Stargate in Texas with, just line after line of combined cycle gas power plants on top of these massive data centers. What do all these projects need? They need concrete. And look at the scale of the projects that are being announced right now. Look at the $10 billion plus announcement in northern Louisiana, and many others are just being announced day after day, it seems. And the idea of concrete being such a small sliver of the program, but at the same time, when you scale the aggregates and sand and cement that needs to get to site, you got to build a railroad. We're having to rethink how we scale the delivery of materials. So concrete quickly becomes on the critical path to get the foundations in, which allows us to get the structures up. And getting dried in is a fundamental step in any data center project, because that's when the real work starts. As you know, the mechanical, electrical work kind of trumps everything else with the scale of it, but we can't start any of that until we get that building dried in. So that's just one example of how important concrete is in this day and age.
Yeah. We should probably back up a little bit can you explain why there's such demand for data centers for folks that may be not familiar what a data center is?
So a data center is a warehouse that we put computers in. It's not a especially complicated building. It has like 4 systems. It's got a power system. It's got a shell or an envelope. It's got a mechanical cooling system, and it's got fiber optic connectivity. It's really those 4 systems. It's not a clean room. It's not anything super scientific. It's just like a Volkswagen that you put a V8 in. It's a small, simple shell with a really powertrain in it. And then now with the advent of AI, the cooling is becoming more complicated. So over the last 25 years in North America, we've gone from 0 data centers to like 35 gigawatts of data centers. And that is the unit of measure for data centers. We don't measure square footage or cubic, area. We measure how much IT or information technology capacity a building can manage. And that's called IT capacity, and it's measured in megawatts, which is a very big unit of measure in power. So that said, we look at where it's evolved. Well, what does it evolve for? It's evolved as a place originally to put compute and storage workloads. What is that? Why is that important? Well, before the cloud happened, all of your big enterprises had like their own computer room, and they had like some servers in there, and they had some IT staff, and they had to do all the stuff to manage their own internal infrastructure, both hardware, software, and personnel. And it's very expensive and it's decentralized. Everyone had to like roll their own, and even small offices had to make investments. So the cloud shows up as a value proposition that says, hey, we can give this to you as a service, software as a service, infrastructure as a service, and you just pay when you're using it. And we'll hire we'll buy the hardware, we'll house the hardware, we'll have the IT staff, and suddenly the cost for the IT component of many businesses just drops down, makes it much more efficient. So this is how that whole game started, and it's grown, and it's started in some of the concentrated areas that touch demographics, that touch key connectivity nodes, fiber optic nodes, like Northern Virginia. It's gone crazy if anyone looks around that area. Phoenix, Dallas, Fort Worth, Central Washington State was actually a big area, and you go on and cite these clusters. So over the last 25 years, 30 gigawatts of power have been installed across all the plant. And this is before we could even really get serious about AI. And AI has changed the game because AI is another level of compute capability that allows us, and we're all talking about it today, what it can do for us, how it can change our life, how it can simplify things. So that is spiked demand even greater. So what we see from now until 2030, that 35 gigawatts on the low side of estimates will grow to about 60 gigawatts, doubling. That's the low
Mm.
side estimate. The high side is about 90 gigawatts in North America by 2030. That demand is that core compute and storage I discussed earlier, about 9-10% of that. And the rest is these AI training centers. You see these big facilities out in the middle of nowhere. They're training, they're creating a neural network that creates a brain, and that brain creates general intelligence, the algorithm. That's a Grok or a Claude or a Copilot. And then it gets monetized. It has to get monetized, and it gets out to people. When you grab your phone to say, hey, solve this problem for me, AI. Now you're inferring, now you're using it, and that's a whole another area of demand. So it's these three areas of demand that stack up: compute and storage, the traditional workloads, training AI models to create general intelligence, and then inferring it, putting it to work and monetizing it.
Yeah. And yeah, so when they first were starting to build these things, like Northern Virginia was kind of the place where it all sprouted from.
Yeah,
And now
yeah.
we're seeing them going out to rural areas, which is getting a lot of attention lately. I think people that live near these projects that are being thrown out there are starting to pay attention to, just because of information that's put out there that might not be totally true, might be partially true on the resources that the data centers use. But can you talk a little bit about why we're seeing more of the data centers being built in the rural areas versus near the cities?
Oh, yeah. So we again go back to those three, demand streams. That compute and storage wants to be close to demographics that they serve, wants to have a low latency experience for people using that product. Like if you had a 911 system for New York, you want your data center really close so it's performing fast. It's one idea. But when we talk about training workloads, the AI training to create the algorithm, it doesn't need to be connected to the world. It's not serving customers. You can have this isolated, massive data center, and you just dump a bunch of data into it so it can train itself. It's literally getting all of these servers in synchronization, and they do a number of load profiles that they get in sync, and they think, and then they pause, and then they assimilate. I'm not a smart guy about the exact functions, but it does not need to be connected necessarily to you know the closest concentration of demographics and fiber optic neuro centers, if you will. So that is what we're seeing right there. And we should also call out that Bitcoin mining is a form of data center as well. And they're also not latency sensitive. They are just, mining coin, if you will. And they don't have to be anywhere particularly close to the historic areas. So those are some of the things driving rural development of data centers. And I think also causing some of this NIMBYism, not in my backyard, is some of them in the rural areas, particularly, I'll just say it, the miners, they're pretty scrappy, and they're kind of noisy. And there's been some negative outcomes around what that feels like to have that big development around you. You also recognize in a rural community, you're building data centers, and suddenly out of nowhere, there's just all these trucks running up and down the road, destroying the roads, making it unsafe for people, just making people uncomfortable. And it's change, and we're all, as humans, a little resistant to change.
Yeah. So when we're moving out to rural areas, it was already pretty demanding to keep up with these schedules. Yeah, the data center schedule, construction schedules are compressed
Yeah.
because they're got to get these things up and running so you can start
So
collecting some dollars.
everyone's in a race to make the best algorithm. That's right.
Right. So we're moving out to these rural areas, and it's even more challenging to get your labor and your materials out there. So can we talk a little bit about what is important on the we'll just focus on the concrete side because that's all I know. So the concrete side of what I guess first of all, we had a great discussion before we hit record, by the way. What is what is the ownership or the developers that are building the data centers? What do they want from their concrete? Like what's top of mind?
That's a great question. So it's kind of important to understand the market of data centers. As much development as you see everywhere, if you really go back to who the customers are, it's really like less than 10 outfits. And it's the big hyperscalers that we know, like Google, Microsoft, Meta, Amazon, Oracle. So these are the folks that are driving the spend of that big wedge we talked about of demand. It's mostly those players right there. You got some neo cloud and others, but that's where the real demand comes from. So you look at what's driving their capital programs, and they have two things they can do. They can make it or they can lease it. So you'll see data centers being built by QTS or other digital bridge, these really big outfits that are delivering, but they're serving that hyperscale customer. Or the hyperscale customer will build for themselves. So 70% of data centers are built by third parties, 30% built by the hyperscalers themselves. Back to your question, what do they want? Well, they all have a little bit of a different personality. Some want to go really fast. Some want to make sure that they're really environmentally sensitive. Some want to find that balance. In general, we find that they are all driving against some ESG requirements, meaning there is still some environmental social governance that they've been driving that they will continue to drive on because they're global companies. So they're worried about their emissions. That's why you see the investments in renewable energy. That's why you see a lot of work in understanding what the scope 3 emissions are in data centers, which is the embodied carbon in all the materials. So that's one piece of it. They also they're in a race. They're in a commercial race to build the best algorithm the fastest so they can monetize it, just like you said. So they want speed. They want cost effectiveness. They can offer their services at a better rate, and they want an understanding of their materials that reduces their environmental footprint. And a thesis that's emerging among them, most of them, is that the way we can really drive that efficiency is by making our designs leaner, simpler, and really honing in on using less. So what does all that mean to concrete? Again, you could look at this pie shape that would be all the materials that go into a data center. Half of it's mechanical, electrical equipment and wire and piping. The other half is like the other last quarter's the building itself. So you got some concrete in there. And then you got all the site work, the roads and the substation. But in aggregate, you might get 10% of the total project is concrete. The challenge that we have is we know also that concrete after steel has some of the highest embodied carbon in it. So that created a tension by the customers, the end users. Hey, how can we make this better? So there was a coalition across the data center providers to say, hey, how can we get more recycled content like fly ash and slag and other novel posolins to get in there and allow us to use less cement? And can we get it to cost less? And can we get it to be viable? So a lot of work was done with that. AI was actually used. But what we learned is that the buy cycle to get to folks like Baker Construction is through the general contractors. And the general contractors don't really care in the grand I'm being a little facetious, but don't really care in the grand scheme of things who's buying the concrete because they got so much other stuff to buy. You were telling that story earlier. It's like, yeah, no harm, no foul, Seth, but you're not my most important thing right now. I got to get a bunch of copper in here. I got to get a bunch of chillers and all this other stuff.
Right.
So, so we're not controlling the opportunity. So if we have like 4 different places that are using concrete and everyone's getting their own concrete, and by the way, we're building power plants next to these big gigawatt centers, we're missing a huge opportunity because everyone's kind of competing for the same aggregates, the same sand, the same cement. It's not coordinated. So A, we can create a bottleneck of supply on which is a relatively small material, but critical for getting these buildings dry, like I was talking about. And then if we're driving towards like, hey, can we get a mix design that we think works better, and we're working with the Amrises of the world, or gosh, what's the other one top of my mind? It'll come to me. How do we get commonality of these mix designs? How do we get that to the batch plant? How do we make sure we have this consistent material? And you're seeing it in your business right now. You're seeing these pilot projects. They're saying how can we get low carbon AI designed concrete into our projects? And to do that, we have to break these silos of how we procure both concrete as a bulk product, concrete that's mixed in the batch plant, concrete that's formed and placed. And we got to be much more intentional, and we got to get past the general contractors in the same way they give. I think you're missing this, the mechanical electrical subcontractors, they get a lot of, they're at the table. They're right there, they're at the table. We need to get our concrete supply chain at the table so we have a coordinated, method to really get the best value out of our concrete and the best efficiency.
Yeah. Well, I think a couple things there. You mentioned that concrete and its large CO2 or carbon footprint, and that's just based on volume because the amount of concrete that's used in the world is the most used man-made material on Earth. If you took a unit of concrete and compared it to steel, there's vastly different. Yeah, yeah. It's
Ball something,
so
yeah.
when someone says concrete has an intensive amount of carbon that it puts out in the world, it's partially true and partially false. It's based on volume. It's just used so much.
That's right.
So the other but what you mentioned there, I think this kind of solves the challenge at hand is the design. So if they can skinny up the design, they would use less concrete or less cement. The cement is the one that gets all the attention in there. But if they would skinny up the design, they would use less concrete, and that would use less or emit less carbon as well. So
And it would cost less, and it would build
yeah,
faster, which are
yeah,
other
yeah,
other pillars that is really important to everyone. Yeah.
yeah. So that to me, that one would hit a number of those goals that they have. I appreciate someone. I used to scoff at these guys that would create these new concretes and cements and everything, but I
Right.
think what someone pointed out to me was what's great about these things is that we're innovating here in the U.S. So it's kind of a way of starting reshoring manufacturing here in the U.S. And I thought that was a great point. So encouraging those guys to keep working. It's just I become skeptical because those things are hard to scale. At least the ones I've
Yeah.
seen out there. So there's a point where those don't.
100%.
Yeah, yeah. So it's gonna be hard to scale, but I know there's pilot projects out there, and they're trying to come up with new things. So it may have its use case in some of these projects, but to kind of take over the entire industry, it's just totally skeptical at this point. But I look forward to being proved wrong. So yeah, that I appreciate you sharing that because that's all. When we get these RFPs, it's like, hey, we want less carbon, but we want
Right,
our
right.
concrete done fast and quick, and we want it
Yeah.
now. So it's like when you're a concrete contractor, it's like I just want to beat my head against the wall sometimes. It's
Where are
like,
you gonna get it? Can you get
yeah,
enough of it? So it's Heidelberg is the other supplier, I think, one of the major
yeah.
suppliers. So yeah, there's all this innovation that we're seeing, like algae concrete or some other concrete, and you basically get a Ziploc bag full of it, but you can't get it at scale.
Mhm.
So I think the strategy to get low carbon concrete is to really work with those suppliers so that they have a base product that comes to you, in a normal supply chain. Yeah, yeah, I want this type 2 or whatever those types are that you're getting in there, and then making sure we're specifying poslums and other substitutes that are they're available at industrial scale. And it takes discipline, I think, and pre-planning. I think about concrete on a gigascale project. It needs to be one of the first things you think about. Why? Well, first of all, we got to get a logistics worked out. There needs to be a railroad coming in for all the stuff for that massive construction project. We need to figure out where the batch plant's going to be, and if we're going to do, substitute cementitious materials, where are they coming from? Are we going to mix it in situ right there? So, where's that supply chain coming from? Let's make sure that we understand the locally sourced aggregates and sand. We understand all the dynamics of it, how it's going to behave. We should be testing all of that stuff while we're doing our grading. We should be making everything dialed in. So then, when we're ready to really go, we got our supply chain set up. We got our mix design confirmed with all the real materials that site is actually going to use. And then we can do a few, test mock-ups, make sure we all know how to finish it and everyone's happy. You like it, everyone's good. Then we just go and execute. I think that's the level of coordination and the silo busting that we have to do to really get the best value out of our concrete programs.
Yeah, I agree. That was an easy sell, Doug. Is there any other thing you wanted to make sure we discussed today?
Yeah, I would say that concrete is also showing up in the power space, obviously in the foundations. But I was just with Skidmore, Owens and Merrill, one of the biggest architectural firms in the world, and they're looking at how to solve this pumped storage. How do we unlock the intermittent characteristics of our utility, whether it's mismatched demand with mismatched supply, whether that's renewables that aren't being accessed or producing power we don't need it, curtailment of workloads, whether it's a gas-fired generator that's pumping and staying going but doesn't have the workloads. How do we store that energy?
Mhm.
So one of those ideas is they want to build a 620-meter. That's like, 3 times taller than a wind turbine that can hold enough water so that it turns a turbine and creates a gigawatt of power for an hour. I mean, that is
Mhm.
like it'll unlock a lot of the utilities that we need to grow to those big numbers I was sharing with you. And some of the solutions we're looking at, gravity batteries, which is basically hoisting up huge blocks of concrete. And they're learning a lot about Energy Vault, that company, learning a lot about the mix designs and the reinforcement designs, a disaster at first. So a lot of more coordination needed with the industry. And then this 620-meter tower is literally a high-rise building in the middle of nowhere that is going to need a mountain of concrete and a mountain of logistics. So we talked about AI being an effective use to get more sustainable materials in. One more call out is we're using deterministic large language models to make our steel designs more efficient. Okay, why does that matter for concrete? Well, if you apply the same logic to rebar designs, we use less steel, which costs
Okay.
less, sits up faster. It displaces less concrete, so we use less concrete and we can build more. So I think we got to keep pushing for those incremental innovations and make sure they're scalable as we go. Just want to illuminate some of those different use cases that are showing up.
Yeah, what about the other building systems, other servers themselves and all that? I assume there's some design efficiency going on there. I mean, these things are going to get more compact because your weight of your building has a lot to do with how much concrete you're using as well.
I think that's right. I think the point load on the surface on these slabs is going to get higher because the density of the servers. If you look at the systems inside, the servers are getting smaller and more
Uh,
dense. They're able to run at hotter temperature, which is more efficient, which means your cooling plant doesn't have to expand as quickly to keep up with the server density. Power plant has to increase like that, but our buildings are going to get, I think, theoretically smaller, but stiffer, if that makes any sense.
well, this was great, Doug. Did we cover everything for today? I hope.
Absolutely. This was a
Oh, yeah.
great conversation, Seth. I hope I can come back and give you updates as things are evolving.
Yeah. Did talk about your 1,800-foot
That
tower.
thing, beast.
Yeah. All right. We'll get Doug's link to his LinkedIn. That's his preferred way of getting hold of him. So please check out the show notes for that. Doug, thanks for coming on the show today. I appreciate it.
Thank you, Seth. I admire the work you're doing. And as I got into this concrete world, I really found your podcast very informative to kind of quickly get a handle on what's going on in the industry.
Appreciate that. Thank you. Until next time, folks, let's keep it concrete.